Okay. All right. This is group something. This is John Olson, Caitlin Short, Cody Jardine, and then Kyle Russell should be joining us soon. We're doing lesson 22 group meeting. So let's start on the quiz like usual. See if I can find the right window. There we go.
True. Is the first one too?
Yeah.
2.0.
Yeah. Make sure you throw that in.
Nope. 1.5.
Yeah.
Now we're getting back to the stuff that I actually know how to do.
This is like basic. Ridiculous.
Yeah, super sweet. So if x is 16, then 16 times 5 is 4, minus 3 is 1. Y equals 1?
No, not minus 3.
Oh, isn't that minus 3? Negative 3.0 plus 2.5x?
Oh, I didn't see the negative sign.
Yeah, it's friggin' hidden in there.
Okay, 1.0?
Yeah, I think 1.0.
Okay.
Okay, make a scatter plot. Oh, another friggin' download.
Oh my gosh.
Right. Give me 20 minutes, I'll go find the file.
Alright.
Math self-efficacy.
Didn't we already download this one from last time?
Yeah, something.
Oh, yeah, we did. There it is.
I just wanted to fill up my hard drive with more
Just downloading it again. Yeah, that's not a bad idea.
Okay, so let me pull up this quantitative inference for procedures.
So which one do we put it in on the
last tab.
The last one? Okay.
Before the one that says version, the linear regression.
Okay.
But yeah, it should be the linear regression or whatever.
Okay, so that's in. What's the question? Scatter plot.
So let's see here. It says make a scatter plot of the self-efficacy data of the 3 data shapes introduced in reading which shape best describes this data. Should probably look at what the reading said about that.
Hamburger, banana, hot dog. Looks like don't know.
Looks like a lot of dots.
I'm thinking a hot dog.
A hot dog?
Yeah.
Okay, so let's see here. A hot dog shape is like long and skinny. A hamburger shape is kind of like fills up the whole screen. And a banana shape is like it has a distinct curve to it. So
I agree with the hot dog.
Yeah, I think hot dog as well. Definitely doesn't curve, but it is like long. Okay.
That's a stupid question. If you were going into a career that used statistics, it's not like you would be in a meeting like, that's definitely a banana-shaped Scatter plot.
Yeah. Careful. Watch out for this data. It's banana shaped, so we may lose money on this. So based on the shape of the scatter plot you produced in question 6, what can you say about the appropriateness of using simple linear regression to model these data? So, hot dog shape means conduct regression analysis to determine if there is a significant linear relationship. Linear regression. So hamburger, it says it's not appropriate. Banana says it's not appropriate. So I think simple linear regression is appropriate for these data. That sounds like it's written poorly too.
Yeah, but I agree with that.
The last one?
Yeah.
Yeah.
So then how many observations are in the math self-efficacy? Let's see here.
Is that just asking for
I think it's just a count of how many data sets.
like how many scores they observed?
Yeah.
Right?
I think so.
139.
Does it spit that out?
What? No, it doesn't show it anywhere, but in the file it goes down to cell 140, but there's a label in cell 1.
Cool. 139. Okay, for questions 10 through 13, use the mouse efficacy. Be sure to use the confidence data for the explanatory variable and the score data as a response rate. Oh, okay. So, which one did I put where? Let's see here. Did I lose you guys? You still there?
We're still here.
Okay. So it says
I
which
did
one?
them backwards.
Which one's supposed to be which? Like 700 windows open.
Confidence is X and score is Y.
Okay, so we need to switch them.
So we just type in score.
No. So you just need to make sure that the data files that all go. Oh shoot! I just screwed up my file. The data that's called whatever.
Yeah.
I'm so sorry. I'm just so distracted. Okay, so the data that says confidence, so that's like the 1 point or the 4.4 and the short numbers, the little numbers. That needs to be in the X column, which is the first column, and then your scores, which is like the 50, 83, 70. That needs to be in the Y column. So mine got screwed up. Undo. Thinking.
So score is in the Y and the other one's in the X. Okay.
Copy. Paste. Boom. Copy. Alright, that only took me like an hour to figure out. Okay, so the y-intercept. Pull up the lesson again.
So is it just what's under B?
That's
And
right.
okay. So did you guys get 18.559?
Yeah, I did.
Okay.
John, are you still here?
Yeah, I'm still here. So yeah, y-intercept b. Okay. Yeah, I just was reading through the lesson to try to figure out which one was coming out. So then it would be 12.725.
Yeah.
So then, if x equals 4, then you just go equals 12.75 times 4 plus 18.559. 69 point. I mean, the answer should be exact. I was like 69.459.
That's what I got. Well, because there's also on the spreadsheet.
Does it have a place you can drop in numbers?
Yeah, right above the scatter plot.
Oh, x right there.
Yeah, you just
4.
change it to 4, and you get the same answer as
Oh,
calculating it.
Perfect. Okay. Our life's hard. Okay, so the confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? Your answer should be exact. Because there's a positive correlation with the largest x value to find the largest predicted y value.
So I went through all of them, and there was one y that was 100, and the x for it was 5.53, but then there was an x that was 5.87, so that's the highest x.
The highest.
And its y is 93. So I think the answer is 93, based on his hint.
I have a 6. I found a 6.
Oh, really? Oh, yeah, there it is, 97. Right? There's another 6 that's 93.
Yeah, 93.
Okay, I found a 6 that's 97 in row 82.
697, yeah.
So
What
would it
does
be
that
97?
mean? So what is the maximum predicted value of y? Which one's y? Y is the score test, the test score. What is the maximum value of y of these values of x? And because there's a positive correlation between
Oh.
the largest x value to find the largest predicted value of y.
The largest y would be 6?
You just throw. Well, don't you just throw x into the formula and the predicted would be 94.901?
What?
Okay, so what if you throw in instead of putting 4 into that x box, what if you throw 6 into that x box?
Oh, I see.
So you get 94.909?
Yeah, but I don't know. Is that what it means?
It makes sense. I don't know what he's asking, though.
What is the maximum predicted value of y? Yeah, I think that's right.
I think that's it.
So 94.090. So how many explanatory independent variables are present in simple linear regression? There's only one. I don't know if that's true. Let me guess.
You sounded pretty confident, though.
So explanatory variable.
Really?
And then how many I think it's 1 and 1, but I actually don't know. I mean, that's what it seems right. For every one x value in simple linear regression. So basically what we're saying, in simple linear regression, you're just doing 1x to 1y. So you're just saying, like, you're looking at how confident they were and seeing how good their test score was. So you could do non-simple linear regression, and you could do, like, how confident you were combined with how many hours you studied on the test, combined with how many, what your quiz score was, and that would give you a guess of what your test score would be. So that means you would have more explanatory variables and still one response variable. But in simple linear regression, you're just doing 1-to-1.
Right. Well, it's also like if it's linear versus like a parabola.
Yeah. Yeah. All
So
right.
I think 1 and 1.
Yeah.
I'll go ahead and submit.
Okay.
100.
Perfect.
Sweet.
Yes. Oh, I got 93. I missed one. I think I dyslexia number 12. Yeah, I did.
Oh.
Oh, I did 090 instead of 909. Whoops. That was dumb.
All right. Same time Tuesday.
I think so. Let me check real quick to double check when my game is supposed to be.
You have a game. Something. You might have a game.
Is it posted?
Hmm?
Is that posted? I'm checking mine too.
Okay. Our game's at 8:15, so would 9:30 be okay to do it late?
Yeah, that's fine with me.
Guess what? Depends on what Caitlin has, but
9:30. You're thinking
yeah,
on Tuesday?
yeah.
Yeah, I have a game at 10:15, so we should be done by then.
Okay, we'll just be quick.
Let's just make sure we start exactly at 9:30.
Okay, all right.
Yeah, that
sounds
shouldn't be a
good.
problem.
Cool. All right, we'll see you guys 9:30 Tuesday then. And
Okay, have a
Caitlin,
good night.
if you have any questions on your thing, just shoot us an email or whatever.
Yeah.
All right. Thanks,
Okay.
guys.
Yep.
Yep.
See ya.
See ya.